Hi everyone, myself Arun Kumar from SNS College of Technology in the Department of ECE. In this video, we are going to discuss about open loop and closed loop systems in control system modeling. So these are all the slides we are going to see in this video: introduction, open loop system, closed loop system, activity, and followed by assessments. Okay, understanding the input connections, it is comes under DT empathize. So before going to implement input system or output system to the corresponding control unit, we need to consider which type of input signal and output signal has been forwarded, because there are two type of control systems has been enabled for operating the control units. First one is open loop system and second one is a closed loop systems. It is based on the input signals and output signals. Let me see how these input and output signals has been defined with the help of both the open loop and closed loop systems. Defined. So in this we are going to execute the number of elements which are to be used in this control systems. They are using input signals as a reference input plus symbols, and moreover it is also act as a summer. We need to add or eliminate by using this summer unit. And next one is, if you are having signals from the summer unit, it will be passed to the controller elements. Here we are using the controller blocks like g of transfer function of the system has been used, and moreover it has been done with the help of feedback elements loop along with the additional block systems, so that it will be communicate to the neighboring devices or neighboring controllers based on the feedback loop signals. Suppose if you are having any error in the particular unit, then automatically the error has to be resolved by using the reference input to the summer unit. Open loop control systems. The open loop systems is purely based on the input signals and output signals. It does not depend on feedback unit, because it is a open loop system. Once if the conditions or input has been enabled to the particular controller unit, then automatically it may be stopped based on the output conditions. So here they are given about the controller unit and actuators, and the disturbance. Suppose if you want to add or any signals to the signals, then we are using the disturbance here, and the plant is nothing but the controllers and sensors. So once the information has been given, then automatically it may be moved towards the destination. Examples: washing machines, they are using in our home, in our daily lives. Once if they are assigning the particular programming to the washing machine, then automatically it may be stopped based on the input conditions. The closed loop system. The closed loop system has been operated based on the feedback systems. Without feedback, it may not be operated, because uh, once the information has been processed from the input signals, then automatically it may move towards the controller, actuators, and plant and sensors. Then it may be the output has been given to the input of the signals. Suppose if you want to eliminate any errors of the system means, then we can use the systems. Suppose if you want to add any unit means, here also it is possible to add more number of operations. Examples: air coolers, or in car system we are using air conditioning based on the temperature monitoring systems. Suppose in cruise control car systems, automatically the air cooler has been operated with the help of the temperature of the corresponding atmosphere, so that it can be operated based on the feedback loop systems. Feedback loop systems are based on input signal R, and E is the error signal. Suppose the feedback has been generated error means, then we need to eliminate the errors. And G is the forward path gain, the controller loop, and H is the feedback system, and C is the output of the system, and B is the feedback signal, corresponding signals. Then that overall system transfer function can be calculated by 1 by 1 plus G of S, G into H. 1 by, suppose the G H means, then we are automatically having 1 by 1 plus G of H. So the difference between the open loop and closed loop systems, by it is having a feedback element, it doesn't have any feedback element. The closed loop system, almost feedback is the main primary element. Next one is open loop is error directory is not present. Here the error directory is present. It is a stable one. It may become unstable, because we are finalized the input and the feedback signal, so that it is unstable. easy to construct, and it's a more complicated because more number of additional devices has been added, so that is a complicated constructions. Mind mapping, open loop, closed loop system. The open loop is doesn't have any feedbacks, whereas closed loop is having a feedback. And moreover, it's a department and output. Independent on output is a open loop system. So the task given is group discussion. Open loop is closed loop control systems, which is more suitable for modern industrial applications. Take a time for 25 to 30 minutes. We are going to complete this group discussion, and take a group as 6 to 8 students, and consider to analyze the industry purpose cases and the real-time applications. Assessment. Which industry mainly uses closed loop control systems? Textile drying, smart manufacturing, cements, simple heating devices, manual irrigations. So the smart manufacturing is the right answer, so that they are using more number of control unit for closed loop systems. And second one is which statement is true? Open loop systems are always unstable. Closed loop systems never have error. Feedback improves the system performance. Closed loop systems don't need the sensors. The answer is feedback improves system performance, because almost all we are giving the feedback to the system so that the correct answer has been given, so the performance also improve. So these are all the slides I have taken for this video. Thank you.